In the previous video, we trained a model, created a SageMaker endpoint, and verified that it was serving predictions successfully. Now, we will configure SageMaker Model Monitor to continuously monitor that endpoint and detect data quality issues and if any data drift. So, steps 1 through 5 are already completed. In this video, we will focus on steps 6 through 8. To do that, under Model Governance, select the model dashboard, then select the model we created earlier, choose the endpoint and click on Create Monitor. The first step here is enabling the data capture. Since we already enabled data capture while creating the endpoint, SageMaker has automatically populated the same settings for us. You may also notice that SageMaker is asking for a new endpoint configuration name. I'll provide a name such as Loan Data Capture Config. Earlier, we created an endpoint configuration as a part of the endpoint deployment process. Here, SageMaker is updating endpoint configuration specifically for the data capture settings. This is required because Model Monitor does not collect data by itself. Instead, it relies on data capture to record the request and predictions generated by the endpoint. Since we already configured these settings earlier, most of the values are automatically populated for us. So we will simply review the configuration and continue to the next step. Now we are in the step 2 where we configure the monitor type and the baseline dataset. So the first option is a monitor type. SageMaker provides 4 different monitoring options. Data quality monitoring checks whether the incoming inference data matches the expected structure and characteristics of the training data. It helps identify issues such as missing columns, unexpected values, schema mismatches, and data drift. Model quality monitoring evaluates how well the model is performing over time by comparing predictions with actual outcomes. This helps identify performance degradation after deployment. Model explainability monitoring helps us identify which features are influencing the model's prediction and tracks the feature importance over time. Model bias monitoring helps identify whether the model is making unfair predictions for different groups of users based on selected attributes. So for this demo, we will select the data quality because our goal is to monitor the data being sent to the endpoint and detect issues such as data quality problems and data drift. Next, we need to provide the baseline dataset S3 location. This should point to the same dataset that we used during model training. SageMaker uses this training dataset as a reference to understand what normal data looks like and generate baseline statistics and constraints from it. So in our case, I'll select the loan dataset that we uploaded earlier to Amazon S3. So go to S3 bucket, select the input file, copy the S3 URI, come back to the baseline configuration and paste it. Now the next option is S3 output location. So this is where SageMaker will store the baseline statistics, constraints, and monitoring reports if any. To keep things organized, I'll create a separate folder dedicated to model monitor outputs. So now go back to the S3 bucket and click on create a folder. Provide a folder name such as baseline output and then scroll down and click create a folder. Once the folder is created, open it and copy its S3 URI. Then return to the SageMaker and paste the URI in the S3 output location field. Now under configurations, for the baseline instance type, select ml.c5.xlarge. Before proceeding, make sure this instance type is available in your account quota. Again, to verify this, go to the service quotas, make sure you are in the same region, search for ml.c5.xlarge and select the quota for processing job usage. Next, click request at the account level and set the requested value to 1. Please do not request a value greater than 1. So requests for a value of 1 are typically approved automatically without requiring manual review from the AWS support team. Higher quota request may require additional approval and can take longer. Now click request. Once the quota increase is approved, return to the SageMaker and continue with the setup. Now why we are choosing an instance type in this step? So SageMaker will launch a temporary processing instance using the instance type we specified. This instance analyzes the baseline or the training dataset and generate statistics and constraints files, which are then stored in the S3 output location we provided. So this is the baseline which will be stored in the S3. So in simple terms, a baseline is a reference point that represents what normal data looks like. And please note that once the baseline statistics and constraints are generated, the processing instance is automatically terminated. So once these settings are configured, click next to continue. Now in this step, we configure how and when the monitoring job should run. First, provide a schedule name. I'll use Loan Data Quality Monitor. This is simply the name of the monitoring schedule that SageMaker will create. Next, select the IAM role. This role gives SageMaker permissions to access resources such as Amazon S3, CloudWatch, and other services required to run the monitoring job. Here, select the same IAM role that we created earlier while setting up the training job. The schedule expression determines how frequently the monitoring job runs. For this demo, I'll set hourly, which means SageMaker will automatically run the monitoring job once every hour. Now think about what happens after a model is deployed. The endpoint may receive predictions every minute, every second, or even thousands of requests throughout the day. As these requests arrive, SageMaker can capture the incoming data and store it for monitoring purposes. Now, based on the schedule we configure, SageMaker periodically launches a monitoring job. So during each run, it compares the recently captured production data against the baseline statistics and constraints that were generated earlier from the training dataset. If SageMaker detects significant difference between the production data and the baseline data, it can identify issues such as data quality problems, data drift, or constraint violations and generate monitoring reports in Amazon S3. Now, for the monitoring job to run, SageMaker need compute resources. That's why we need to specify an instance type here. Now, this instance will be used whenever the monitoring schedule runs. Now, for this demo, I'll choose ml.c5.2xlarge. The reason I'm not selecting the ml.c5.xlarge is that we already requested a quota of 1 for that instance type in the previous step while creating the baseline. As you may remember, requesting a quota greater than 1 typically requires a manual approval from the AWS support, which can take some time. So to avoid waiting for additional quota approvals during the demo, I'm choosing a different instance type for the monitoring job. However, if you have enough time to prepare in advance, you can request the required quotas beforehand and use the same instance type for both processing jobs, the baseline creation job and the monitoring job. Now, using the same instance type can also help simplify the setup and potentially reduce cost. For this demo, however, I'll continue with the ml.c5.2xlarge and make sure that instance type is available in your account quota. Again, to verify this, search for ml.c5.2xlarge this time and select this quota for the processing job usage. If it is 0, click on request increase at account level, change it to 1 and update it. Once it is approved, go back to the SageMaker configuration. A single instance is enough for our workload and the default storage allocation should be adequate for processing the monitoring data. Now going back to the stopping condition, it specifies the maximum amount of time the monitoring job is allowed to run. If the job exceeds this limit, SageMaker will stop it automatically. Now we will keep the default value, and by enabling the CloudWatch metrics, SageMaker publishes monitoring metrics to Amazon CloudWatch. This allows us to visualize monitoring results and create alarms if required. So we will keep this option disabled for now. And finally, we need to provide an S3 output location. So this is where SageMaker will store the monitoring job results, reports, statistics, and any violations detected during monitoring. Now go back to the S3 bucket and click Create a folder. Give the folder a name such as Monitor Output. Scroll down and click Create a folder. Next, open the Monitor Output folder, copy its S3 URI, return to the SageMaker and paste it into the S3 output location field. The encryption and VPC settings are optional. Since they are not required for this demo, we will leave them unchanged and proceed to the next step. The options in step 4 are advanced and optional. Record processor source URI allows us to run custom pre-processing logic on the captured data before SageMaker analyzes it. And post analytics processor source URI allows us to run custom processing on the monitoring results after the analysis is complete. Since we don't have any custom processing for this demo, we will leave both options empty and submit the monitor. Now do a refresh. The monitoring job has been successfully created. Initially, you will notice the status is pending. After a few minutes, the status should change to scheduled. Now that the monitor schedule status has changed to scheduled, it means the model monitor has been created successfully and is ready to run according to the schedule we configured, which is every hour. Now let's send some inference request to the endpoint and see how model monitor analyzes the captured data. So it will compare the incoming production data against the baseline statistics and constraints that were generated earlier and identify any violations if significant deviations are detected. Now before we proceed, please keep one thing in mind. In a real-world environment, a model may receive thousands or even millions of prediction requests over time. With a large volume of production data, any change in data distribution are easier to detect, and model monitor is more likely to identify data quality issues or data drift. Now in this demo, however, we are only sending around 30 records to the endpoint. Because the sample size is very small, we may not observe any significant drift or violations, and that's completely normal. The objective here is to understand the monitoring workflow. The process remains exactly the same whether you are working with a small demo dataset or a real production workload. Now open a new tab. At the top of the AWS Management Console, you will see the AWS Cloud Shell option in the navigation bar. So click on it to launch the Cloud Shell. Before you proceed, make sure it is in the same region where you are performing this hands-on. So this ensures the Cloud Shell opens in the same region and can interact with the resources you have created. Now let's run the following command. So here I am taking approximately 30 records from the inference dataset and saving them into the payload.csv. This file will be used as the input for our endpoint invocation. Next, let's invoke the endpoint. This is the same endpoint invocation command that we used earlier, and I have already explained its parameters. So I'll go ahead and execute it. Once the command completes, run cat output.txt file. This displays the prediction generated for all 30 records that were sent to the endpoint. At this point, we have successfully sent the inference data to the endpoint and generated the traffic. However, the monitoring job has not run yet. So since our monitoring schedule is configured to run hourly, we need to wait for the next monitoring execution. Once the monitoring job runs, SageMaker will analyze the captured data, compare it against the baseline, and generate monitoring reports. After that, we will check the S3 output location and see whether any violations or deviations were detected in the inference data. Now after an hour approximately, refresh the page and you can see the monitor now in the alert state. So this indicates that the SageMaker model monitor has detected an issue and generated an alert. To investigate further, navigate to the Alert History tab and click View Executions or switch to Execution History. Here you can see the monitoring job execution along with their execution times and statuses are updated. Now if you notice that one of the execution is in failed state, let's say. So don't worry if you see this in your environment. A monitoring job can fail if there is no captured inference data available for analysis. So remember, Model Monitor compares the captured inference data with the baseline dataset. If there is no inference data available yet, SageMaker doesn't have anything to compare and the monitoring job may fail. So seeing and failed execution is completely normal and does not necessarily indicate a problem with this setup. Now wait for at least one execution to complete successfully before checking the result. So as I have one, let's start with the steps. First, verify the data that was captured from our endpoint. So go to the data capture folder in Amazon S3. Inside this folder, you will see the records that were sent to the endpoint for prediction. Now if I download one of the files, you would notice the inference request and the response that SageMaker captured when we invoked the endpoint. Now if I download the other file, you will notice that it contains both the input data sent to the endpoint and the prediction returned by the model. This is the same data that Model Monitor uses for analysis. Now go back to the S3 bucket and open the folder where SageMaker stored the baseline artifacts. Here you will notice the files such as constraints and statistics. These files were generated from the baseline dataset that we provided earlier. The constraints file has identified the 4 columns in our training dataset and generated validation rules for them. For example, SageMaker has determined that all the 4 columns contain the integer value, has no missing data, and are expected to contain only non-negative values. And the statistics file contain the numeric summary of our training dataset. For example, SageMaker has calculated that the dataset contains 40 records. So if you see our training dataset, it has 40 records excluding the first row. Okay. The average age is around 32 years and the average income is 51,000 and the average loan amount is around 15,300. It also records information such as minimum values, maximum values, and the distribution of data for each column. Now let's open the monitor output folder. So this is the most important folder for us because it contains the results generated by the monitoring job. So navigate through the folders until you locate the actual output file, which is constraints_violations.json. So this is a file that tells us whether Model Monitor detected any issues when comparing the inference data with the baseline data. So download the file and open it. To understand this violation, let's compare it with the baseline training dataset. Now as you can see, the baseline training dataset contains 4 columns. However, the inference data that we sent to the endpoint was not interpreted in the same structure as the baseline dataset. So while our baseline dataset contains 4 separate columns, SageMaker appears to have treated the captured inference payload as a single field during the monitoring. So because of this schema mismatch, Model Monitor generated a missing column violation report. That's exactly what this violation report is telling us. So according to the baseline constraints, SageMaker was expecting 4 columns, but the monitor data did not match the expected structure. Therefore, Model Monitor generates a missing columns violation. The important thing to understand here is not the specific violation itself, but the fact that the Model Monitor successfully analyzed the captured data, compared it against the baseline constraints, detected a mismatch, and generated a report. In other words, Model Monitor is working exactly as expected. So whenever the incoming inference data differs from the baseline data, whether due to missing columns, schema changes, unexpected values, or other data quality issues, Model Monitor can detect those differences and generate alerts and reports. So in our case, the mismatch was caused by the format in which the inference data was interpreted, and the Model Monitor successfully captured and reported that issue. So this demonstrates how SageMaker Model Monitor continuously monitors production data and alerts us whenever it identifies potential data quality issues. Now that we have verified the monitoring workflow is working as expected, now let's move on to the cleanup steps to avoid any unnecessary AWS charges. So first, let's delete the monitoring schedule. So as of now, the SageMaker console does not provide a direct option to delete a monitoring schedule. However, we can delete it using the AWS CLI commands. So open Cloud Shell in the same AWS region where you created the monitoring schedule and run the following command. So replace the monitoring schedule name with the name you provided while creating the monitor. So make sure you use the monitoring schedule name and not the endpoint name. Now once the command runs successfully, refresh the page and verify that the monitoring schedule has been removed. Next, let's delete the endpoint. Under Deployment and Inference, select Endpoints, choose the endpoint, click Actions, and then select Delete. Confirm the deletion when prompted. After deleting the endpoint, delete the endpoint configuration. So go to Endpoint Configurations, select the configuration, click Actions, and then choose Delete and confirm the deletion. Next, let's delete the SageMaker model. So go to Deployable Models, select the model, click Actions, and then select Delete and confirm the deletion. You may also notice the training job that we created earlier. Training jobs cannot be deleted, but that's perfectly fine because they are completed jobs and do not occur any ongoing charges. Finally, let's clean up the S3 bucket. So before deleting the bucket, you must first delete all the objects stored inside it. Since SageMaker created several files during the training, deployment, data capture, and monitoring process, the bucket cannot be deleted until those objects are removed. So select all the objects in the bucket and click Delete. When prompted, type the confirmation text and confirm the deletion. Once all the objects are removed, return to the bucket list. Select the bucket and click Delete. So you'll be asked to enter the bucket name for confirmation. Copy and paste the bucket name and then proceed with the deletion. Although IAM roles do not occur any charges, you can delete the IAM role if you no longer need it. At this point, all resources created as part of this demo have been cleaned up successfully. And that's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching and I'll see you in the next video. Take care and happy learning.